Increasing, decreasing, constant, positive, and negative intervals. I have a picture of a function here. We'll call that g of t. In that function, multiple things are happening, and we want to dissect this function so we can identify intervals on which this thing is increasing, decreasing, constant, positive, and negative. That's the point of this video. And once we finish this video, you should be able to analyze any function and attribute these stats or these categories to specific intervals along the function curve. So let's start with increasing, decreasing, and constant. When we look at whether or not a function is increasing, we want to make that observation as the input variable increases, meaning it's moving left to right along the axis, because as we move left to right, the way that number line is formatted, the value of our inputs go up. So that's important. We want to say, as in this case, we have a t variable as our input, so as t increases, I'm just going to put an upward arrow for that, the function itself should increase. So the outputs should increase. So that's the definition of increasing. And an increasing function will have a positive rate of change. So let's go over to our graph here. So as we move left to right, or as the t variable increases in value, the function should go up if it's increasing on a specific interval. So we can see, I'm going to trace along here as we move left to right. This part of the function we see is going up as we move left to right, and so is this. So those two pieces are the parts that are increasing on this function. Now, how do we list where the function is increasing? Well, we want to list the interval along which that occurs. And the interval needs to be from one input value to another input value. So you're doing it from one t value to another t value. Or if this was the x-axis labeled with an x variable, one x value to another x value. So this is increasing from this point on the t-axis or x-axis to this point. What are the values of those points? We're at -4 and +1. So you would say that this graph g of t is increasing from -4 to 1. Again, that is not a coordinate. That is an interval along the input axis, which again is often the x-axis, but in this particular example, it's a t-axis. Now, there could be more than one interval on which something's increasing, like we see a second interval as we move more to the right, and that's going from this point on the t-axis to this point, so from 3 to 5. So we'll put comma 3 to 5. So those are the two intervals in which this function is increasing. And again, those are not coordinates, super important. So what you don't want to do when listing where a function is increasing, decreasing, or constant, positive, negative, you don't want to say from this point here to this point here. So you don't want to list coordinate to coordinate. You're doing an interval along that input axis. So that's increasing. Let's look at decreasing. Decreasing will be as the input variable, in this case t, increases, the function value g of t should go down. So as we move left to right, again, that's what this means. The values of g, or the y values, remember it's the same thing as y, should go down. So let's trace over the parts of the function where that occurs. We can see that as we move left to right, this piece of the function goes down, and so does this. To indicate the proper locations of that decreasing function, we want to use an interval on which the function spans across, and the values are going down as we move left to right. So we're going to say g of t is decreasing. The first interval from -5 to -4 on the input axis. For the second one, we're going from 1 to 3. And there you go. Those are the two intervals on which something is decreasing. You could have no intervals on which something is increasing, decreasing, or constant. You could have just one. You could have infinitely many intervals. So we're not limited to a specific amount of intervals on which a function is going up or down. And then finally, we'll look at a constant definition. So as the input variable, in this case again, t increases, g of t remains unchanged, meaning it doesn't go up or down. So it's going to stay flat. So you're going to see something with a zero slope. By the way, I should have thrown in with decreasing, you have a negative rate of change. Like increasing, we said we have a positive rate of change or positive slopes. With constant, we have zero rate of change. Again, this means staying flat for some interval. Now, on this function here, there is no constant interval. There is nowhere where the function just stays flat over some interval given on this particular example. Okay, so no piece of that function is constant. But what you should be on the lookout for is something that stays flat for some input length. Now let's move over to positive and negative intervals. So what does it mean to be positive and what does it mean to be negative? This is all in reference to the outputs. So when we look at positive and negative, we're just looking at our output values. Now to define positive and negative, a function is positive when the outputs, or the y values, is greater than 0. So what does it mean to be greater than 0 visually? That just means above the x-axis, or the input axis, or in this case, the t-axis. To be negative, your g of t or your y values need to be less than 0, or below the input axis, which is most, again, often x-axis. So let's look at where that occurs for this graph. So we're going to say g of t is positive on what interval and negative on what interval. So when we list the interval, we're still listing along the input axis where this thing occurs, but we're looking for when the graph is above the axis and when it's below. So let's first do positive. We can see that this piece and this piece are above the x-axis or the t-axis. So you're going to say it is positive from this point, -2 to 2, right? This point on the t to this point on the t. So we're going to say -2 to 2, and then from 4 to 5. So this point to this point. Again, those are not coordinates. They are intervals along the input axis. And then lastly, where is this thing negative or below the input axis or the x-axis in these two pieces here? So we're going to say that this thing is negative from this point to this point. So from -5 to -2. And then from 2 to 4. And a good question that comes up often is, do you ever use brackets when listing these intervals? And the answer is no. Always use parentheses. So we're not doing a domain interval or a range interval where we want to indicate if something's included or not in the set. We're just listing from one point to another. So just use parentheses when listing these types of intervals. Now that we have definitions and we know how to identify these 5 types of function behavior or characteristics, let's talk about, when we know what these are, what things we can deduce from a function graph without actually seeing a picture. So a couple things are, if you know that a function is going from increasing to decreasing over some interval, then you have reached a maximum point. You've reached a peak of a mountain or like the top of a hill. So for instance, over here on our graph, we can see it goes from increasing to decreasing at that point. So we've reached a maximum. So that indicates we've reached a maximum point on that interval. If something goes from decreasing to increasing, again, without even seeing the picture of the graph, let's say we're just given that information, we know it goes from decreasing to increasing, like in this point, we've reached a minimum point on that interval. So those are a couple cool things that you can deduce from some given information without seeing the picture of a graph. And another thing you can come up with is, let's say we know a function goes from positive to negative or negative to positive at a point. If you go from positive to negative, like in this location, or negative to positive, like in this location, what you have just identified is where that change occurs. You have just found an x-intercept. And an x-intercept also describes a zero. And a zero also describes a solution to an equation. So we can find solutions to function equations or zeros of function equations if we can know, or if we are given information that this function is going from positive to negative or negative to positive. And again, all that means is it's crossing over the x-axis, and hopefully that makes sense. So those are a couple things that we can come up with given our knowledge of what it means to increase, decrease, stay constant, or what it means to be positive and negative. And if we're given information about changes in those behaviors or characteristics, we can make some conclusions about, do we have a maximum on an interval? Do we have a minimum? Have we reached an x-intercept or a solution? So things like that. That's what you want to be thinking about given this new descriptions of functions and your knowledge of them.